Hi, welcome back. In this video, we're going to talk about how to do a quadratic regression. Now, a regression is really just another word for saying finding the equation of a quadratic given a table. Okay, so the goal for today is to find the equation of quadratic given real life situation, right? And then using that same equation to make predictions about this real life scenario. If you have not watched the other video on attributes of quadratics or applications of quadratics, the application, the real life scenario of a quadratic is what we're mostly interested in. So once we find the equation, we want to answer questions about it and make predictions to this real life equation that we're dealing with. So we'll do a few examples. Make sure you have a calculator out so you can follow the steps on how to find the quadratic regression. And then in the end, I'll give you a recap of the steps that we took to find the equation. Let's get to it with this first example. All right, so here we have a scenario, right? We have a pumpkin tossing contest. Here you can probably see they're not really pumpkins, they're more like watermelons that are being launched through different catapults, right? Whatever angle you use in the catapult is going to result in the farther the distance. So here we have a table using whatever angle you're dealing with will launch a specific distance. Okay, the first part is find a quadratic equation that best fits this data that we're given, and then what angle will give you the longest distance. This is the real life application that we're trying to find out. But let's first find the equation and then answer the question that belongs. To do that, we're going to press the home button and we're going to type in this table in our list and spreadsheets, which is this green button here in the middle. Before you type in your table under A and B, we first need to name these columns. I'm going to call this one degrees. You can use the keyboard on yours to title it degrees, and I'm going to call the second one feet because I'm dealing with the feet of the angles. And then I fill in my table. I have 20 degrees, 30 degrees, 40, 50, 60, 70. Go over to the right side of the table, and I label that 383. 48, 543, 548, 503, 408. You usually want to label the first column your X column and your Y column. If the table is horizontal, the top one is going to represent the X column, and then the bottom one will represent the Y column. Okay. Once you've labeled your graph, once you've labeled your table, we know that we're dealing with a quadratic equation. If not, we can make this table, find an equation, we can find the graph from it, and based on the graph, we can make our predictions from there. But because we know we're dealing with a quadratic equation, right? The question says find a quadratic equation that best fits the data. We're going to go to Menu, Statistics, and under Stat Calculations, we're going to do a quadratic regression. We're going to find the equation, a quadratic equation that best fits this data. And when you do that, you first have to label your X and your Y axis. The X axis we said was going to represent the degrees, and the Y axis was going to represent the feet. As you label it, you'll be able to get the equation of a quadratic. Now, what does all this mean? The general form of a quadratic, is, let me make some space here for you guys. The general equation of a quadratic is yx squared y equals ax squared plus bx plus c. This x squared, let me see. Should be as an exponent. So to make it an exponent, I'm just going to put this caret, right? That's the general quadratic. That's what you see here as ax squared plus bx plus c. Our goal is to put these numbers in for a, b, and c. So all we have to do is replace ax squared plus bx plus c with the actual values. assuming that this 2 at the end is a squared. So we have y equals a value is negative 0.25 x squared plus b, in this term, b is 23 plus 23x plus c, which is 23. So all I'm doing is I'm replacing the a, the b, and the c with these three terms here that I see in my table, a, b, and c. The purpose here is to find the equation. Now, I can take this equation and I can graph it and answer the question that follows. So let's do that. I'm going to go home, go to graph, and let's graph it. When you press the tab button, it'll take you to the graph. Let's type this in as negative 0.25 x squared plus 23x plus 23. As I graph it, I realize that I can't see the whole picture, so I'm going to zoom out a little bit. I can press menu, zoom. Zoom fit is one thing that I like to use. Zoom fit allows me to zoom out a little bit. I still can't see the whole graph. So I press menu again, zoom out. And I start zooming out, I can start seeing more of the picture that I'm interested in. Here, this gives me a better view of the entire quadratic. If you remember from our previous video, applications of quadratics, we are not dealing with the negative part of quadratics because that's the under part of the ground. We're dealing with this portion of the graph, the top part of the graph. So now to answer the question, what angle will give us the longest distance? So we want to know which angle is going to give us the longest distance. In this table, we only have 6 angles that we're dealing with. That gives us those distances. And there's more angles, 25, 35, 45, 55, 65. There's a ton of angles between 0 and 90 that's going to give us a possibility. So to find the largest distance, we're going to find this peak right here, this maximum. Anytime you want to follow or find points on the graph, you're going to click these 3 buttons: menu, trace, and then graph trace. This allows you to move the cursor left and right anywhere on the graph. And my goal is to find the maximum point, the maximum or longest distance. So as I start moving it towards the peak, I'm going to go towards this top part, and I want to find the maximum value right there. Now this maximum represents, if you look at the point, represents 2 values right here, 46, 552. What am I interested in? I want to know what angle, so the x value. What x value will give me the longest distance? And that's 46 degrees. The question was saying, what is the maximum height that we can get from any angle? We would focus on the y value. Y equals 552 feet of interest. So you want to identify what the x value represents. In this case, it's the angle. The y value represents the feet. And once you find the point in the graph, you need to interpret, am I looking for the x value or the y value? And here, the longest distance, what angle gives us that? That's going to be the x value. 46 degrees will produce the longest distance traveled in this pumpkin / watermelon launching contest. All right, so that's one example. Let's do another one so we can practice these methods, find the equation, and then use that equation to answer the question or make a prediction about the problem. Okay, so let's go to the next example. In this example, we're standing on the top of the CN Tower in Toronto. We're dropping a penny from the very top. As time progresses, the penny will drop in feet. It'll keep dropping and dropping and dropping until it hits the ground. We want to find an equation that best fits this data. And then, when will the penny hit the ground? Make the prediction of how long will it take for the penny to hit the ground. So let's go back. Let's restart this process. I'm going to go to the table and type in my table. Step 1, type in your table under List and Spreadsheets here in the middle. Before I type my table, I need to define my x and y axis. So my first column will represent time, and my second column will represent distance. How far are you from the ground? So I have 0, 2, 4, 6, 8, and 10. Just make sure you're really careful with what you're putting in. The distances are 1, 8, 21, 1, 7, 57, 1, 5, 65, 1, 2, 45, 7, 97, 2, 21. Once I have my table filled out with my columns labeled, I can now find my equation. Everything will always be under menu. So if you forget, press menu and search through there. We're trying to find the quadratic equation that goes through this. So menu, statistics, stat calculations, quadratic regression. Because I know I'm dealing with the quadratic, I'm going to do a quadratic regression. I just have to label my x and y axis. The x-axis was known as the time, so I search for time. The y-axis was representing the distance, so I find distance, press OK, and here's my equation. Remember, the general equation, let me open this up a little bit. The general equation is y equals ax squared plus bx plus c. I'm going to replace a, b, and c with the ones that I'm interested in, that I got from my table. So I have a here, b, and c. I'm going to replace them in here. So y equals, instead of a, I'm going to type in negative 16. Instead of b, I'm going to type in 0x, and instead of c, I'm going to type in 1821. Once you have your equation, I can graph it and model it to answer this question. When does it hit the ground? Which is what we're really mostly interested in. So let's graph it. I go to graph, press tab, and let's type it in. Negative 16x squared plus 0x plus 1821. Oops. Once you graph it, notice how nothing pops up. I'm dealing with numbers that are in the thousands, so I'm going to really have to zoom out here. Right now I'm at 0, 0. So menu, zoom, let's put fit. Yeah, that pretty much fits the graph. If you want to see more of it, you can move it around. You could even zoom out a little bit more. Menu, zoom out. Yeah, that gives us a better idea. If you watched our previous video on applications, you would remember that we're not counting anything on the negative side. We don't have negative height. We don't have negative time. Anything below the x-axis will not count because we're not dealing with negative ground distance. Okay? You want to really understand the graph of the real life scenario by focusing on the x-axis and the y-axis. I want to know when will it hit the ground. Okay? Usually, the ground represents the x-axis in a real life scenario. So when does it touch the ground right there? To find that point, we press menu, trace, and graph trace the graph. And now I can move this cursor all the way down till it touches the x-axis. 0 value, or the x-intercept. How long did it take for it to hit the ground? Well, time represents the x value, 10.7 seconds. Our approximation. Now, this question could be anything. It could be, what is the initial height of the penny when you're dropping it? What is the height of the building? You can find that here. At the beginning, at 0, you have 1821, or you can look at the y-intercept, the y-axis. This is where it starts, and this is where it ends in the ground. You can ask questions on the table, like what is the distance after 4 seconds? Or you can even ask questions that are not on the table, like what happens at 9 seconds? When it's not on the table, use the trace button. Menu, trace, graph trace, and you can move it around to find the time you're interested in. I want to know what happens at 9 seconds. At 9 seconds, we are approximately 525 feet from the ground. I hope this has helped. If you have not subscribed so already, go ahead and the subscribe button. If this helped you a little bit, even a little bit, click the like button. And here, as we follow towards the last slide, I want to share with you the recap of what we did. There's two things we want to do. Find the equation, and then once you find the equation, use it to make a prediction of a real-life scenario. So we start by making a table. Label the columns. That's a big one. Label the columns as your X and Y's, your X-axis, your Y-axis, your distance, your time, your feet. Then you're going to do menu, statistics, quadratic regression. That will allow you to find the equation. Once you have the equation, we go to graph, we type it in, and then you can trace the graph to make whatever predictions you're looking for. Again, don't forget to subscribe, hit the like button, and as always, we'll calculate later.